All right, here we go. Section 4.8. This is title of this section is Use the Quadratic Formula and the Discriminant. The goal of this section is to solve quadratic equations using the quadratic formula. And you should be sitting back saying, hey, I've solved it taking the square root of both sides. I've solved it by factoring. I've even solved it using completing the square. And the last way that we learn to solve it is using the quadratic formula. And I think you've probably seen it before, but we're going to pretend like you've never seen it. So the formula that gives us solutions to any quadratic equation, I think you should interpret as ones that factor, ones that don't. Anytime you need to solve a quadratic equation, you can use the quadratic formula. The discriminant is a part of the quadratic formula, and it's b squared minus 4ac, and it's a really nice way to get an idea of what's going on with the quadratic function. So we'll talk about that in a couple examples. Here is the quadratic formula if you haven't seen it in a while. Right, so from standard form, we always need quadratic formula to come from the standard form. And we've got a is the coefficient in front of the x squared, b the coefficient in front of x, and c is the coefficient with no x term. And we plug them into the quadratic formula. I would certainly write this on a note sheet that you have, right? You want to make sure you have the quadratic formula correct. Made a cup of tea. Good. So it's negative b plus minus the square root of b squared minus 4ac, everybody divided by 2a. Let's do 3 examples. So the first example, and really key in on it, this is the example where we're going to get 2 real roots, 2 real solutions, 2 real x-intercepts. I can use all those words to describe the same thing. So here's our quadratic equation. Again, we can see it's quadratic because x squared. Our real first step here would be to solve and set equal to 0. Right, so we subtract 6 from both sides. Now we would identify that a is 1, b is 7, and c is negative 6. The quadratic formula comes out again, and we have to place these correctly. Really take your time here, right? If you put the numbers in the wrong spots, your answer is going to be wrong, and that would be disappointing. So it's negative 7, 7 squared. 4ac is going to be 4 times 1 times negative 6. Everything divided by 2 times 1. And then kind of have your strategy. The book here, they squared 7, and then it looks like they're going to add, right? 2 negatives would go positive. I highly recommend that you put all this in your calculator, one step. So really in your calculator, maybe 7 squared minus 4 times 1 times negative 6. Hit enter, and you should get 73. And 2 times 1 is 2. And now, those are the exact answers. If we were graphing, we'd want to know the approximate answers, and that's why they use the squiggly equal. So in your calculator, and I highly recommend that you pause the video right now, take out your calculator, see how you're typing this into your calculator. If you choose to do one line on the calculator, you have to put parentheses around the numerator. You might choose to do this in pieces, so maybe type in negative 7 plus the square root of 73, hit enter, then divide by 2. Again, the calculator, this step to go from here to here is not trivial, so definitely make sure you're comfortable using the calculator correctly. And then you do it again with the negative sign. So again, this is where we solve a quadratic equation, and we had 2 real roots, 0.7 and negative 7.7. So our next example, we're only going to get 1 real solution, and we're kind of curious what's going to happen to us. I gotta say, by the way, I like our book a lot, but I'm frustrated that the book didn't divide this whole equation by 2. I think you should. I think you should always be looking for that. This really, I think, would be easier, and the numbers would be smaller, right? This would be 4 squared. Your arithmetic would be simpler. So whatever. The book decided not to. Again, I would recommend it. Notice here what happens to the numbers under the square root. And this, by the way, this is called the discriminant. That was one of your vocab words. This is b squared minus 4ac. And this right now goes to 0. And because the discriminant, the numbers under the square root went to 0, the plus minus becomes obsolete, right? This is 8 plus 0 or 8 minus 0. And that's still 8. So you only get one answer. It's called the double root. if you were to factor, if you had factored this equation, you would have gotten x minus 2, x minus 2. So you still have two answers, but the two answers are the same. So we call this a solution with one real solution. What do you think's next? Well, we've done two real solutions, now one real solution, and the last example is going to be two imaginary solutions. So these are answers that are not real. They are going to have I in there, and we'll talk about graphically what that means as well. So the steps here, solve for 0, set 0. Again, my step would be to look, can I divide out? I cannot here, right? There's no factor of 2 like the last problem. Plug into the quadratic formula. And then as you start cleaning up the discriminant, notice this is going to be 4 minus, right, because you have 3 negatives, minus 20. And that gets you negative 16. When you take the square root of negative 16, you will get 4i. And so right here, basically the answers you're getting are numbers that don't exist. They are imaginary answers. Notice how we factor down this fraction, right? 2 and 4 are divisible by the denominator 2. So 2 divided by 2 goes to 1. Actually, I should have said negative 2 divided by negative 2 goes to positive 1. And here 4i divided by negative 2 goes to either plus or minus 2i. Good cup of tea. Okay, so you have 4 examples. I would not. You don't need to do all 4. It takes a bit too long. These take a while. So these are 3 different examples. One of them is going to have 2 real roots. One of them is going to have 1 real root, and one will have 2 imaginary. Take the time. I think it's going to take you a couple minutes to do this, and I think it's a good payoff. So go ahead and hit pause, and when you're ready, I'll show you the solutions. And here are my solutions. Again, I apologize. It's really hard for me to write this small with this pen. So I tried to do the best I could. Notice here for problem 1, I saw that all the numbers were powered up by 2, so I quickly divided. I think just for me, the numbers get easy. 36 is easier to square than 12. Not a big deal, but still. Here you should have gotten 2 real roots, right? Square root of 4, the discriminant is a positive number. Take square root of 4, I get 2, if you can read that. And there are my final answers are negative 4 and negative 2. Example 2, notice the discriminant. 20 squared is 400. 4 times 4 times 25 is 400. 400 minus 400 goes to 0. And then basically this disappears, right? It's just 20 divided by 8, which reduces to 5 halves. So if you got this answer, fantastic. And finally, the imaginary one. So again, my first step here is to divide by 3. All my work gets a little easier, and I like easy. Notice, and be careful here, when b is negative and you put in the formula, the 2 negatives cancel and go positive. Be careful with that. And then here you're going to get 4 minus 8, which is going to equal 2 plus minus the square root of negative 4. And that's where your imaginary answers come out, right? This would be 2 plus minus 2i all over 2. And this does reduce. Hopefully you're seeing that the denominator 2 goes into both of these pieces, and you're left with 1 plus or minus I. Nice job. So what is this discriminant? Well, again, we can learn a lot about the roots if we just look at the discriminant. So the discriminant is b squared minus 4ac, and when it is greater, when that number is greater than 0, you will get 2 real solutions. The graph, and this is what's interesting, has 2 x-intercepts. So quickly, if I make up a problem, it would be a quadratic that would cross the x-axis twice. You'd get 2 real solutions. And again, that's when the discriminant is greater than 0. Right? When the discriminant is equal to 0, you only get 1 real solution. That's pretty neat. That's when the parabola, the vertex, is actually the only spot that touches, I got it. Right? Only the vertex is the x-intercept, and that's when the discriminant is equal to 0. And the final one is when the discriminant is less than 0, negative. You can't take square root of negative. Well, we have imaginary roots. So what happens? The parabola never crosses the x-axis. right? And it's always a bad joke, but you can say, hey, can you see the x-intercepts? They're right there. They're imaginary. Well, they're not there. They don't exist. There are no x-intercepts. So examples here, you've got 3 different quadratic equations, and for all of them, you can tell whether or not the roots are real or, oh, I got visitors. I'm at home today. And so here are the 3 possibilities, right? So the first one, A, you found your discriminant to be 16, and so you're going to have 2 real roots, right? 16 is greater than 0. The next discriminant is equal to 0, so you have 1 real root. And then finally, you have negative 16, which is the square root of negative 16 would give you imaginary answers. So here you go. If you could try example 5, 6, and 7. And all I'm asking you to do here is to tell me what the discriminant is equal to, and then if from that information you should be able to tell me if there are 2 real roots, 1 real root, or 2 imaginary roots. Go ahead and hit pause, and when you're ready, I'll show you the answers. And so here we go. First one, you have 2 imaginary roots. So again, the discriminant, you should be looking, and again, please on your formula sheet, write it, b squared, squared, handy dandy pen, squared minus 4ac. So you're just plugging in numbers into those, and once you crunch the numbers, if you get negative 4, you have 2 imaginary roots. Here we got positive 4. That means we have 2 real roots. Again, don't worry if you didn't get the roots. I wouldn't. You've done enough of that. And then finally, the last one, the discriminant is equal to 0, and you have 1 real solution. Sounds good. And we will see you in class.